Hello, everyone. And if you don't know who I am, my name is Michael Salati. I am primarily an Angular developer hailing from New Haven, Connecticut. I will warn you, a lot of my code and some of my snippets will be written in Angular. However, I'm going to be trying to go over framework agnostic concepts and cover tooling across the three major front-end frameworks. Besides my love for Angular, I love the web. I grew up on the web and remember how things were like in the mid-90s, the 2000s, and now even our modern web environment. And I love it. It's compelling, it's exciting, and we have incredible tools to make amazing and compelling experiences for others. I'm currently working on a dream side project, which is a MAS service. And if you guys aren't familiar what MAS stands for, it's Memes as a Service. Please stay tuned. You'll be able to order memes by mail in the upcoming months. And most importantly, I have made a lot of mistakes. I'm hoping I can share with you some of my experiences so you won't make those same mistakes that I have. And who knows, maybe by the end of this talk, you'll see a mistake in real life. So, first question, what is a PWA? And the answer to that is fairly simple. It's, oh God. I wasn't supposed to do that. A PWA is not that. PWAs are supposed to be following three basic concepts. They're supposed to be reliable. So they should load instantly. Never show that dinosaur that we saw before. Even in uncertain network conditions at 2G, 3G speeds, and especially important in emerging markets, or if you have T-Mobile and live in Maine. They're fast. They respond quickly to user interactions with silky smooth animations with no janky scrolling. Unlike if you live with T-Mobile in Maine. And finally, they're engaging. They feel like a natural app on your device with immersive user experiences. Think about your push notifications. Think about the app icons. Think about being able to install things onto your home screen. These are things users expect from a native application. So for your progressive web app to be progressive and an app, these are the same sort of experiences that you want to share with your users on the web. So why is this all important? Simple. Building a high-quality progressive web app has incredible benefits, making it easy to delight your users, grow engagement, and increase conversions. When progressive web app criteria are met, Chrome will prompt a user to add the progressive web app to their home screen. Service workers allow you to send less data for initial page loads and less data to complete the first transaction and paint of a page. Web push notifications increase engagement, allowing users to get updates on things, statuses, posts, or maybe a shipment order, as well as it gives you the opportunity to try to re-engage them into your application. When users are typically averse to installing apps from the Play Store or App Store and rather visit the website, like me with Facebook, I hate the Facebook app. Sorry, I'm not going to bash on Facebook too much today. A lower barrier to entry, like a website, may be all you need to be a citizen on their home screen. So let's take a look at our sample, simple PWA. It's just a simple application designed to showcase popular movies. And if you click on a movie, you can drill down and view more information about the movie. It looks a bit like a mobile app, only because it does follow material design guidelines, as well as doing a few other performance bits under the hood as an Angular application. However, is it really a PWA? Let's see if I can figure out the mouse. And so you can see just by running, we're going to run a Lighthouse test, which is going to take a few seconds. It's running. And it gets a report. And you might see some reddish circles up here. So is that a PWA? Not really. It got a lousy score of 54 from Lighthouse, which there's a lot of failing parts there. I mean, When the application was offline, it didn't respond with a 200. If you're building a progressive web app, you're going to want to use a service worker so your app can continue to work offline. The user wasn't prompted to install the app as a PWA. Browsers can proactively prompt users to add your app to their home screen, which can lead to higher engagement for your applications. It didn't register a service worker. Service workers are the technology that enable us to use many progressive web app features, such as offline use, adding it to the home screen, push notifications, and more. There was no fallback when JavaScript was unavailable. Even if the user's device has JavaScript disabled, it's important to show a user something. Google, luckily, will run some of your JavaScript for, I think it's up to 5 seconds of JavaScript code when they're rendering out your application while they're crawling it. But that means your application needs to finish rendering within 5 seconds. Other browsers or other search engines like Bing, and there's Russian and Yandex, thank you. I was going to butcher the pronunciation. They're not going to run your JavaScript, which means when they crawl your pages, they're just seeing blank pages. And if you're dynamically adding metadata, they're not seeing any metadata either. There was no custom splash screen. When you open up an application on your cell phone, you're usually greeted to something as the rest of the application loads in the background, or as the OS starts to get things ready. And there was no address bar color. If you use Chrome on Android, you'll see on some websites that the address bar kind of matches a similar color as the nav bar. And that might affect the status bar as well, the coloring there. So, in short, our application was not reliable because it didn't work offline. It wasn't fast because we weren't really caching anything. And it wasn't that engaging because we didn't prompt users to install our application. We didn't have the ability to push notifications. It didn't have the pretty colors in the nav bar, anything like that. Now, I did mention Lighthouse before. And I know there's a possibility that some of you do not know what Lighthouse is. Lighthouse is an open source automated tool for improving the quality of your web pages. You can run it against any web page, public, private, something that might require authentication. It has audits for performance, accessibility, progressive web apps, SEO, and more. Lighthouse is built into the Chrome DevTools, but you can also run it from your command line or as a node module. All right, we saw our application. Let's try to make this a little bit better. The first thing that you would want to hopefully try to do is make the application more reliable. When launched from a user's home screen, a service worker will enable a progressive web app to load instantly, regardless of whether the application was online or offline. Sorry, whether your device was online or offline. A service worker is written in JavaScript. It's like a client-side proxy. If you want to imagine your application making network calls, this is just going to be one thing that sits in between it. If the assets and resources, or if that call has not been made by the service worker, it'll allow the call to go through. The call will fetch the data. It'll be returned. The service worker will cache the result of that onto the local device. And then the rest of the information is still passed to the user. If you're offline, the service worker will see that you're offline. And instead of making the fetch for the same resource that you had already done before, it'll return that resource it already cached for you. Or possibly it could be things like assets, like images, or your bundles that load up your application, the index.html page, the entry point. All these things the service worker can cache for you. And it doesn't have to just be as a fallback. Let's say you're dealing with users who might be in less than ideal internet connections, so that you don't want it to be as a fallback. You want it to be a first solution. That way they don't have to depend on the internet to see things that they've already seen. In the example of the movie application, it's not like I need to update or pull that information every hour. And so the user doesn't need that either. We can cache that information for a couple hours. We can cache that information for a day on the user's device. It saves them internet. And in some markets, you do have to pay by the gigabyte or even the megabyte. And it saves you resources as well. If you're paying for your server, you might want to cut down on bandwidth of users connecting. If it's already on the user's device, they don't have to refetch that data. It saves you. and they're really, really easy to implement. If you're an Angular developer, you just have to run this command into the terminal, ng-add @Angular PWA. It'll add the Angular Service Worker package to your project. It enables the Service Worker build right in the CLI. It imports, registers the Service Worker into the app module. It'll update your index HTML. It'll even do extra steps like installing icons for the PWA. And it creates a Service Worker configuration file called ngsw-config.json, which specifies caching behavior and other settings. So the Service Worker can automatically prefetch and cache all static assets for an application, making it so that if, let's say, the user loads up their application, they lose connection, and then they try to continue to use the application to view states or pages that they haven't been to, it'll still work. And even if the internet connection is available, things still load faster, just because some of the important resources are already there. If you're a React developer, as of 2017, Create React App has included service workers and PWA support right from the get-go when you create your application. Little work needed. And I do believe also, I might be mistaken, last year there was a React CLI announced. Again, not a React developer, so I don't know these things too well. But service worker support is included in there as well. And if you're a Vue developer, Vue has one of the best supports for service workers and PWAs in general. When you go to create your Vue application, you can select right from the get-go that you want to have your app be a PWA, and you'll have your service worker, all with your Vue create command. And so now, with the service worker, we're going to start to see a little bit of an improvement as soon as I find my mouse. Lighthouse audit is running. And our final score ends up becoming up to 81. 81. That is a really good score, and that's all with just a simple usage of a service worker. But we can do better than that. We've gone from a non-reliable app to at least we're reliable now. But we're still not fast enough, and the experience still isn't that engaging. So, if we want to be faster, let's talk about that. 53% of users will abandon a website if it takes longer than 3 seconds to load. And once loaded, users expect them to be fast. No janky scrolling, no slow-to-respond interfaces. Luckily, with our service worker, we configured in our previous section. We've configured this in our previous section, and we've addressed a lot of these concerns. However, we can still optimize the initial page load, parse, compute, and rendering of our applications. If you guys ever have the chance, there is an amazing developer, Adi Osmani. He wrote a really, really good article about the weight of JavaScript, I believe, and it discusses how JavaScript can take a long time to parse and load and how that has an impact on devices. I definitely recommend taking a look at it when you get the chance. And this is important because it's not just the JavaScript that's being sent down the wire to the client's device. It's also the time to render out this single-page application. And this takes time. We can, however, take the burden off of a user and put this onto our server with server-side rendering. This is something, luckily, all the major frameworks have decent support for. And as a front-end developer who doesn't really want to, actually, I'll leave this. If you guys want to take a picture of it real quick, go ahead. The Angular guide is really good. The Vue guide is really good. The React one is eh. And again, this isn't me like trying to hate on React. I was just looking over it, and this was what I found on their official documentation website. I just wasn't a fan. Anyway, if you're a front-end developer who doesn't want to write a full back-end solution, you can use Firebase. There are cloud functions and they do hosting for your application. You can do some settings so you can direct users to your cloud function to render out your application. And with just a little bit of configuration, it's like magic to you. There's very little you need to do. And I want to see if I can get some of my code up there. So this is going to be a little difficult. Let's see if I can do this. Functions. Can you guys read that? Let me just dispose of this part. I'm going to hope for the best there. All right. So hopefully you guys are able to read. This is for server-side rendering for an Angular application, but simple concepts still apply and shouldn't be too difficult. The most important things are express, functions, and I'm using the file system. And right here, just loading up the Angular application. This is a package for bootstrapping the Angular application, and because I implement lazy loading into this application, it needs to be able to map out the routes. Over here, I grab an index.html that I'll render my application into, which just gets read as a string. And this is really all I'm doing. I have an app-get. It'll catch any route. It'll take the path that's passed in, and we'll pass into the engine. Sorry. Some of the information passed initially from the GET request, the URL of the user, the document, which is just our index.html, our bootstrap application information, and then we're going to send back the string HTML that comes back to us. I did add this little bit, though, this cache control, and this is just so once we render out the page on Firebase, I don't want to have to render it every time a user visits the page. So Firebase does provide CDN, a global CDN, so I can just have it cached on the CDN so it doesn't even get to my Firebase functions. And this saves, again, resources, time, compute. And it's faster for the user, because if it's already been rendered and cached on the CDN, that's what they'll end up getting. Cool. So with a simple step, we're able to make a fast, engaging application by providing server-side rendering. And let's see. Oh, you can't see what I'm looking at. So this is going to be a semi-live-ish demo, and I'm really hoping this works, because I just deployed it. All right. Right-click, inspect. Actually, do you know what I can do to better demo this? I can disable JavaScript. Because this is a SPA, typically the JavaScript would, my bundles would come in and render out the application. If the application is rendered on the server, though, I won't need JavaScript to run in order for it to work. JavaScript block. And I beg you guys to cross your fingers, because I have no idea how this is going to work. What? Is it working? I think that worked. And to better showcase this, if you guys have ever looked at your page source when building out an SPA, if you use Angular, it's probably just AppRoot or something like that. We can see a lot of this stuff has already been defined. So we have a bunch of our, well, that's the Sass stuff that we're not too worried about, but we can start to see parts of Sass. OK, there we go. So we can see part of the application is already rendered out into here, and this is in the page source, so JavaScript hasn't run for this, and this is what the browser is seeing. So the browser is seeing app nav bar, it's seeing the mat toolbar, it's seeing the name. Where is that? There we go. Popular movies and all that. So crawlers are going to be able to see this. If a user has JavaScript disabled, at least they see something. And there's additional steps that can be taken to improve this experience. But I think I did show you some of the code for this. It really wasn't that much. It was just a simple function, grabs any route, renders out the application, sends it back to them. And now they have something that they can look at. So things are beginning to work a little bit faster. Now our experiences need to become engaging. They need to feel like a natural app on the user's device with an immersive user experience. Progressive web apps are installable and live on the user's home screen without the need for an app store. They offer an immersive full-screen experience with help from a web app manifest file, and they can even re-engage a user with web push notifications. The web app manifest allows you to control how your app appears, how it's launched. You can specify home screen icons in different sizes for different types of devices, with what page to load when the application is launched, the screen orientation, if it's going to be portrait, landscape, if the application can rotate, and whether or not to even show it in the browser or just to make it look like a regular application. And this is really simple to do. There's an amazing website called app-manifest.firebase.com. And this bit is fairly simple, and I will actually do it with you guys I will do this with you guys real quick because it is crazy simple. So just give me a second. Yeah. So just set up the app manifest thing. You guys are able to see the URL? No? Okay, hold on. I will delete all of this. OK, hopefully that's a little bit easier to read. I'll leave it up for a second so you guys can grab a picture of that. 5, 4, 3, 2, 1. OK. So, simple. We'll name our app Popular Movies. Short name, Movies. We can give it any hex color we want for the theme, which I'm going to go with some red. And you see right there, instantly changed, so you get an idea of what it's going to look like. Background color, we'll do some gray. In a full screen mode, orientation any. And now, the most exciting part, I'm going to select an icon. I know, it's the best part of building any application. Well, I mean, you want it to look pretty, right? You're not going to be a front-end developer and not want something to look pretty. All right, so generate zip, zip downloads. And so we have our manifest JSON. Zoom out. So all the settings are configured: name, short name, theme color, background, full screen scope, start URL, all these images at all these different sizes. And if I go into the images, well, trust me, those are all images at different sizes, I promise you. And now we're kind of getting to the point where we really have a full experience for a progressive web application. But there's just a step or two left to this. That's really it. We just have to add some of this information into the head of our application. And you'll see right in there, I just have link manifest, which I set to that manifest JSON file that I downloaded. And I did set the meta name theme color, and I set that to be a hex value. And that's so Chrome will know what color to display in the bar. And now, let's try to run our Lighthouse score and see how the application does with all of these quick tweaks. So we have our application here. Let me re-enable JavaScript. Cool. Audits. You guys ready? All right. Boom. I don't know if you guys can see it, and I'll zoom in a little bit. SEO, 100%. Best practices, 100%. Accessibility, 100%. And most importantly, that progressive web app, we're up to 100%. There's a few little things I could probably still do to improve the performance of this application, and I'll do that maybe another day. But how many of you guys here have an Android device, just by a show of hands? All right, a little more than half of the audience. What I will ask of you, and I hope it's not too much, if you can just visit https://movies.ngpwa.com. And just check it, and hopefully it actually works, because like I said, I deployed it at the start of this talk. I have not tried it. So I don't know if you guys have what I have, but you should see the red nav bar, name, stuff. If you click into a different movie, information will still load. You might have been prompted to install the application in the bottom. Yeah, go ahead, add it to your home screens. I promise I'm not tracking you guys. And actually, I just realized my phone's in airplane mode. I turned it into airplane mode at the beginning of this because I didn't want it to go off, and it's still loading. I don't know if you guys can see, dragging for refresh. Application still works in airplane mode. I invite you guys to do the same too. Anyway, we've now built an application that is reliable, fast, and engaging. There's simple tools for every framework that you use, whether it's Angular, React, Vue, or other ones as well, which I don't know too well. Anyway, sorry if this talk was a little long. I gift to you all a potato. I'm available on the web, on GitHub, LinkedIn, Medium, Twitter. My name's Michael Slotty, and on all those things, it's just @MichaelSlotty. I am open to questions, concerns, criticism, and most importantly, praise. Thank you. Oh, yes. Okay. I'm going to try to answer the question, but just to repeat in case people didn't hear, I'm fairly confident your question was, if a user was linking into other pages in the application, how will those pages load? More or less. This might require some configuration on your part with Webpack. From what I understand, the most popular tooling will handle a lot of these things for you automatically. With Angular, it's done almost automatically, and it's just one small configuration I had to do in the routing. Okay, this is too big. I can't actually see what I'm doing. App routing module. And so I just have this preload strategy of preload all modules. However, there are configurations that you can set on your A tags to tell the browser to start to prefetch pages, which is completely framework agnostic, routing agnostic. I think it's, I don't remember it off the top of my head, but it might be like fetch prefetch, some setting prefetch. So you can tell the browser to start prefetching these pages. It doesn't block the rendering or any speed application. It does it in between frames or when the user's inactive. So that would probably be a really easy, simple solution. And the fact is, if a user loads up a route or a component that's a reused component, like in the case of my movies, it's the same component for every single page. The only variable is the ID that I pass to the route. If a user visits it once, then anytime they visit that, that type of page again, the component has already been cached. It's a non-issue. It's really just the assets and resources that I'm fetching for that movie, whether that's the image or the movie information. So kind of. Okay. I unfortunately do not have an answer to that. I do not believe they behave that way. Only because I think it would be a weird experience if you just happen to, by chance, visit a URL and to be forced into the PWA experience. I am not sure, though. So in my experience, I haven't seen that. Are there any other questions I can? Yes?
Do any of the tools that you're using here help with apps that support offline editing to get that data synced back up to a server?
So the tooling that I have gone over and discussed does not. However, there are fairly simple solutions that are native to the browser that you could use. There is system storage, which you can cache information onto until the next load of the, until there's an internet connection. And the browser does provide information about the state of the application. I know there are some companies that have developed PWAs where they do occasional polling to see when a user is connected and disconnected. If you use a tool like Firebase, I know you can watch the state and see if the application is offline and have strategies for when the application goes offline. But none of the tooling that I've discussed directly addresses that. In the back.
Right. So just to follow up on that, Chrome supports background sync and service worker, which allows you to send data. We'll check if ways to get it online and then send that data out for you. So it's something that's supporting Chrome right now.
Okay. So just to kind of rehash what he had mentioned, the gentleman in the back for everyone else, Chrome does support a service worker doing the setting and saving information up to the server in the background for you. Not official spec yet, but it will be, and Chrome is already supporting that. And the, as I mentioned earlier, the application does set up a service worker module, at least on the Angular side. So you do have direct access to the service worker through Angular as well. Yes? So the question is, what's browser support for service workers? And I will say for Chrome and Firefox, it is strong. I would assume things like Opera are good as well, just because I'm fairly confident Opera uses Chromium. However, Apple's service workers are interesting. Some things work, some things do not, and I know that is getting better, but it's not full support yet. I believe there's a website called caniuse.com, which discusses support for different browser features and functions and how they work across browsers. Like, I have not even bothered considering Edge anymore, or IE, but I'm willing to bet Edge does support service workers only because I know Microsoft has pushed recently PWAs on Windows 10 from what I recall. I think it's Can I Use. I can... Yeah, it's one of the suggested. Let's see what it does. Oh, service works. Boom. OK. So yeah, it looks like iOS Safari, we are good. Opera Mini is no. IE Mobile is no. BlackBerry, that's dead. And regular IE is no. But Firefox, Chrome, Edge, Safari, regular Opera, Samsung, which is built off of Chromium, I think, Chrome for Android. A lot of these things do support service workers.
There's percentage of focus of these.
Oh, OK, yeah. So 85% of users will have access to a service worker if you use one. Anything else? All right. Thank you guys for being an excellent audience and asking pretty good questions.